Hi, my name is Madison Cieslak, and first of all, I'd like to thank everyone for coming today and listening to my capstone project. My capstone was done on nitrate concentrations left behind by corn, soybeans, and carrots. So, a little bit into the intro and the background. What led me to this specific type of project was the overuse and excess use of nitrogen and nitrate based fertilizers in the agricultural community. Um, Nitrate leaching that's happening, whether there's crops in the soil or not, is leading to health concerns like blue baby syndrome, which summed up is when the nitrate in water supplies, when given to infants 0 to 6 to 8 months, is altered to nitrate. And from there, it alters the form of the hemoglobin into methemoglobin and inhibits its ability to carry oxygen throughout the body. So they're left having a bluish tint in cyanosis. From there, also, it's affecting field rotations and yield outcomes. Farmers are seeing that they can't really find a common ground for how much fertilizer they should be using in their fields. It's kind of become a guessing game. And lastly, the nitrate acidification and the overpowering of it is leading to a lower biodiversity in the soil. It's taking out the healthy microbes and bacteria that they use to grow. So my hypothesis for this experiment was that the nitrogen levels that were going to be measured and collected in the water runoff through pots that had seeds and plants in them was going to be less than those that had water runoff through non-planted soil pots. And a secondary result that we had talked about and had looked in was that the nitrogen levels were going to be different in the varying crops that were used. We found out later in the research that all of the three plants that I chose were a fibrous root system, which means that they have a very thin root system and they have a high level of absorption for nutrition and substances. So we are interested to see what the variance with those would be as well. So my methods. This top picture up there, it's a little dark, but that'll be the setup. So we were set up in the Cazenovia greenhouse right down the hall here. We had 70 total pots. I had 10 for my control, 20 for corn, 20 for soybean, and 20 for carrot. The initial idea was to get a baseline result and then conduct 3 further testing dates after that, after a calcium nitrate fertilizer was added. We had a bit of a hiccup, though. So baseline results were gathered in late September, and when the nitrate fertilizer was made in the chem lab, we converted liters to milliliters, but neglected to convert grams to milligrams. So when we did the procedure, the calcium nitrate fertilizer was in fact added to all 70 of the total plants, whether they were in the testing groups or not. So in there we had to do a little bit of rinsing. So over a 2-week period, there were 3 separate dates where we did about a liter's worth of water, rinsing through each plant to get those nitrate levels down. And then a little bit of how we did it was there were 10 from each of the experimental groups and the 10 control were used. Each plant was set up on the top of a large funnel held up by a ring on a ring stand. From there, there was a smaller funnel which had filter paper in it to catch any soil runoff. And then 50 milliliters of DH2O was run through each plant, and nitrate testing strips were put into the contents of the beaker, and from there, that's how we got the results. So up here right now, there's my week 1 of the raw data. This was my baseline data before any of the calcium nitrate fertilizer component was added. Zeros across the board. It's what we expected. The soil that we planted in didn't have any sort of abundance and any sort of nutrients, so this was what we were looking for. Going further, this is my week 4 results. The control had a high of 10, a middle value of 5, and the lowest was 0. Corn and soybeans seem to be leveling out at the end of the experiment for having a range of 0 to 2 within the two groups, and carrot was at 0. The entire 4 weeks, carrots remained at 0. There was no increase or change. And we'll talk about that a little bit later. So on the left here, we have my control, and on the right, corn. One thing to note is that they do look rather similar, but the scale on the control is 0 to 25, whereas the scale on corn and moving forward is 0 to 2.5 and lower. So what we see in the control is we had a pretty steady like number of values. The highest value that we got in week 2 and 3 was 20. They leveled out, and we had a high value of 10 in week 4. Corn plants gave us no values in week 2 following the first week of nitrate added, but they did increase and have measurable values in weeks 3 and 4. Soybeans had a similar story to corn. Weeks 2, they had a very low calculated value and measurable with the nitrate testing strips. They did, however, have the mean pulled up by a few outliers. And then weeks 3 and 4, they stabled out, similar to how corn did. And carrots over on the right, I'm not sure how easy it is to see in the back there, but they have 4 very, very thin lines to represent that we stayed at 0 throughout the entirety. At the top here, there's the summary of the ANOVA analysis that we did. One thing that we did take a look at is the average and the similarity to their variance. Carrot, soybeans, and corn stayed relatively close to their variance, while control had a much greater range in value, which was expected due to the higher values that we saw in my control. And the big thing up there highlighted is the p-value that we got. It did end up being significant and showed that there was some impact that the plants were making on the amount of nitrate tested and measured in the water runoff. From there, we took it one step further and continued to do a t-test analysis on the week 4 data between the groups. 4 out of the 6 ended up being statistically significant. Control to soybeans and corn to carrots ended up not being significant. We weren't really sure what that was due to, but that's just how it panned out. So for the results, the original hypothesis was that the lower values of nitrate would be found in the soil pots that had crops planted in them, which we found was true, and it wasn't due to random chance. There was some type of impact that the plants were making. And the secondary result was, or the secondary expected result was also observed. We saw the similarities between corn and soybeans, but we saw that carrot sort of deviated from what they had shown. And then just for you guys to see on the right there, there's the testing strip when we had a very, very high value of nitrate. And once we had finished the nitrate or the water rinsing through the pots, what the nitrate value came out to thereafter. So a little bit of the discussion. So the carrot data and why we might have seen this trend. I can't say for certain, but I do think that it could have been due to the chemistry error in the rinsing that followed. They measured, before we moved on with the testing, we got to about 5, 1, or 2 as a measurable nitrate value. And from there, it could have been due to they were so low already that the carrots were just able to take up everything that was there. We may have rinsed out too much, but we won't know. The fibrous root systems and how all 3 of them had it, we didn't realize that that was the case prior to the start of the experiment, but it did seem that all 3 plants had the effect to take up a lot of the nitrate that was added to them, regardless of the rinsing or not. So if I could do it again, I definitely would want to use a different type of root system, see the comparison that might happen through that. And I definitely would want to repeat it without the chemistry error, and maybe use carrots again to see if we see a repeat in this trend with zeros throughout the testing weeks. And then the lower but not zero levels from corn and soybean, what I had determined was that that related back to the initial problem that we're seeing and the increase in research that's happening towards it, is that regardless of how much we're adding and regardless of if it's calculated amount of nitrate or not, there is still some being left in the soil and left to spread to other places. Questions?